À la limite, on peut mettre même le floatum de ce bord-là. C'est pas un setup traditionnel.
Moi, je trouve ça look tellement ça.
Non, hein?
Ah, c'est un left.
Un left tighty.
Un left tighty. Right aussi.
All right, here at IRF 2019, and I am with...
Phil from Dyze Designs.
Very cool. And what drew my attention to you was the fact that you have a drum set here that's completely 3D printed, obviously except for the hardware and the skins, but can you tell me a little bit about that and kind of what you guys are about?
Yeah, of course. I'll start with the drums. So the origin of Dyze Design was actually that I wanted to buy a 3D printer to build myself a drum. So it was more than 5 years ago. And that brought me to trying to make some extrusion system more reliable. And this is what a Dyze Design is about. And the drum set we have here, we use our pellet extruder to build it. The printer we used was a 3D platform, so we had plenty of space for all the shells. And it was a very cool project. We bought a used drum, removed all the hardware, take a few measurements, and then made some 3D shells with our design software. And then we printed the shells, drilled a hole, and bring everything back together. And now it's working.
And do you actually have like the full set with the cymbals and everything, and you play it in the band?
Not yet, but I think it's a project that in a very close future we want to do.
Very cool. So as far as what you guys do, can you tell me a little bit more about that?
Yeah, so the goal of Dyze Design is to make 3D printing more reliable and to push the limits. So we are very specialized in either high flow volumes like the pellet extruder and the Typhoon extruder, which are designed to output a lot of materials. But also we are specialized in high temperature and very sturdy extrusion system like our Dyze extruder and the Dyzen.
Well, why don't we, and that's what these guys are over here, right?
Yep.
So why don't we go over there and we can take a look at them a little bit, and maybe you can tell the viewers a little bit about what you got.
Yeah, of course. Good idea.
All right, so I see two very odd-looking extruders here. So this is obviously more of an industrial type of application, correct?
Yeah, definitely. So this one here is the Typhoon. It's a filament extruder that is designed for 2.85 millimeter filament. And this one here is the Pulsar, and it's designed to work with pellets. So if I go deeper into the technical details of this product. So this one has 4 driving wheels to bring down the filaments, so it works very well with flexible filaments. We were able to extrude about 750 grams per hour with a Shore 80A. So it was pretty fast for this very flexible filament like this. What's special about this unit is the shape of the base body. So it has a weak point where it flexes. So we use that for 2 main features. The first one is auto bed leveling. So you can touch your bed physically with the nozzle, and then there's a
little sensor in there?
Yeah, exactly, a strain sensor that detects that it's moving a little bit, and we are talking about 0.05 millimeters, so
right.
It's nothing big. So you can auto bed your level with your nozzle, so there are no more offset that you need to measure or anything. It's right on the right position.
Yeah.
Exactly. But we also use it on the other way. So when the motor pushes the filament, you can sense the force and the pressure inside your melting zone. That way, if the user has configured the filament wrong, if it's extruding too fast for the extrusion system, you can have a feedback on it. And also, if you don't know a specific material, you can use some kind of routine to map what's the proper feed and speed
That
for
pressure, back pressure, yeah.
yeah,
Okay.
exactly. So we'll be using this feature a lot to give more feedback on the extrusion itself.
Also act as kind of a jam notification and sensor as well.
Yeah, exactly. So if the force goes too high, we know the limit of this extruder. So we can set a threshold and then mark an error if there's something wrong. And we are working with the firmware at the moment to implement all these features. And also we'll have a filament follower inside. So if there's too much slipping, if there's a break in the filament or anything like that, we'll be able to either adjust the flow or again mark an error and stop the print.
Very cool. How about this guy over here? This is more of a pellet. Like I've seen. Are you familiar with the Part Daddy?
No, I haven't seen this one.
The Part Daddy is like an 18-foot Delta printer that was made by CME CNC out in the West Coast or East Coast. No, we're on the East Coast, out in Michigan area, and it's got like a huge hopper that just sucks up big pellets. So.
Wow. So I think it's very similar. So this one might be a smaller version of that. So this one can output about 2 kilos per hour for the moment with PLA. So we have a few nice features with this one too. So we don't have an actual hopper in there. We rather use a venturi system to bring the pellets with air so that the head can be lighter. You don't need to bring the whole weight from the pellets with you. So we have a sensor out there, and every about 3 to 4 minutes there are new pellets that are brought in using the air. And also we have a nice feature with the screw itself. So as you probably know, each polymer needs a different screw to be optimal. So we want people to reach maximum speed with it. So right now we have a general screw which is more designed for PLA, but we'll have screws for TPU, for PEI, for PEEK. So we'll be able to change the screw, and just by loosening a few bolts, you'll be able to remove the barrel and the screw together and put a different one if you want to change your whole setup.
Now, obviously, this isn't targeted towards like the consumer, you know, at the home.
Yeah.
So this is more of a, you know, big companies prototyping and stuff like that. Do you have any of these actually in play out in the industry?
So we've just started sending these. So we are in a beta program right now. So there's, for example, Filament Innovation that managed to cut his printing time for prosthetics from 34 hours to only 1 hour using the Typhoon with flexible filaments. So we are starting to see people installing these in their printer and give us feedback about how they like it or what problem they have with it, and we'll improve it over time and have a final version maybe next year.
So that was going to be my next question, is like what kind of things are you think are going to get printed? And you said prosthetics for one with the TPU. Is there anything else that you know that's actually being printed with these guys?
So we have a lot of projects with these that people want to test new material that are hard to do with filament. So I don't have any particular example, but I know that the pellet extruder will be used with different kind of filler materials. So we've seen carbon fiber, glass fiber, but I think we'll see a lot of very dense metal powder or maybe new types of filler that were not possible to be made in filament before.
Gotcha, I see. Some bulk material that nobody really wants to take the time because there's not a market for it. Understand?
Yeah, exactly. We use like Marlin and do it, and we hope that the work we do to implement all these feedback features will be used by other users to make a simpler version of that and like make.
So are you open source?
For now, no. These are not open source designs because these are very complicated to machine, and all the gears, the heat treatment. It's not something you can, for example, print or machine on a conventional machine. So it's very tricky to build it yourself. But the whole, like, since most machines are built on open source firmware, I think it's a very good opportunity for us to be part of the community and share our custom codes and all the new features that we want to add with the community.
And what's the price tag on something like this? Just curiosity.
Yeah, this one is 2.5 grand, so 2,500, and this one is about 8,000.
Okay. Yeah, if you're gonna do big stuff, you know, it's gonna pay for itself pretty quick.
So with the Pulsar, sorry, what we say to our consumers is that the price of the pellets, for example, with PLA, you pay between 25 to 30 bucks a kilos for filament. Well, with pellets, it's around 4 to 5 bucks a kilo when you buy them. So once you have extruded a few hundred kilograms, it doesn't take that much time when you go 2 kilos per hour, then you're back on your money quite quickly with that product.
Very cool. And I'll provide all kinds of information in the description as to where you can find these guys online and everything. And I appreciate you taking time to talk to us.
Thanks to you.
Thank you very much. Keep watching. There'll be more inside the mind of Matt. Happy printing. Be safe pouring.